Hello friends, it's David Cuartillas, co-founder of Arduino, and I'm here today to present a video of an experiment I made a couple of days ago, and I recorded it in a different computer, so you have to excuse the quality of the sound is not as good as it typically is for the livecast. But in this video, what I'm doing is I'm working with MATLAB, and I connect it to Arduino Uno. As you know, MATLAB is a really powerful piece of software that is used to do a lot of mathematical operations on huge amounts of data at super fast speed. And there is three ways in which you can connect Arduino, different kinds of Arduino boards, not just Arduino Uno, but I will do it with Arduino Uno. So you can connect these different kind of boards to the MATLAB software environment. And the video will summarize the three of them. The first one is going to be to use a serial port as a standard serial communication protocol. The second one is using some sort of tethering technique like Firmatta for Arduino, but in this case for Simulink, including more libraries that are pre-compiled and uploaded to the board. And the third one is using Simulink blocks to create your own code and upload those blocks, that model, onto the board. So I let you with myself, a different version of myself a couple of days ago, and I hope you will enjoy this video.
Use of MATLAB as a tool for capturing data. And the experiments I'm going to show, they just require making use of an Arduino Uno board and MATLAB software. So the first thing I'm going to do is to use the Arduino Uno board with the code you see on the screen. This is a very simple script that I call LTU identifier IDN, and IDN is ID number, and it's because different devices respond to the command asterisk IDN question mark and then send back an identifier. So I made a sketch that reads the analog port A0 and is by default in manual mode, and it's going to read commands that might come from the serial port and respond to them. By default, I only implement one command, that is asterisk IDN, but you could implement other commands. A command always starts with an asterisk, so what we see here is that we check whether the serial port is available, and if it's available we read it, and then if we got an asterisk we will just go to the function process command. So there's a couple of functions at the bottom of this program, but for clarity they are named in a way that they clearly express what they're doing. And by default the system is not sending anything, and once it gets the command asterisk IDN question mark, it responds. And on the other hand, if we change the mode, it will start sending a lot of data very fast back to the computer. So I'm just compiling and uploading to the board, and now it's uploaded, and I will open the serial port monitor to see what we get out of it. So if I send asterisk IDN question mark and I press enter, I get the indication is the Arduino Uno revision 3. If I send a lowercase m, I get a lot of data. I send m again, I change to manual mode, and if I send lowercase a, I will get just one instance of data, as you see here. Okay, so that's how it's running right now, and I will close the serial port monitor and check in MATLAB. For those of you that don't know MATLAB is a mathematics programming environment that allows you doing a lot of experiments with data real fast, and it has a lot of modules. It's a de facto standard in a lot of education programs, but also in the industry. And you can do things like, for example, doing AI agents that run here, get data from different sensors and respond to them. That's just one simple thing where you can do three-dimensional models with data, etc., etc. And it's programmed in a simple way with this scripts that are called live scripts, and live scripts allow you to write and interlace comments and program. What you see here, dark gray or with light gray, sorry, is the code, and the thing with the white background is the actual explanation. And in this case, we're using a default library in MATLAB, which is the serial library that can be used to connect to any serial device. And as you know, the Arduino Uno board acts as a serial device. In this case, we can open the serial port monitor, which is COM13. This is where my board is connected at the speed of 19,600. This command defines the object, doesn't open it. The next one opens the port, waits for a second, sends the IDN command, gets the response, and then it sends an M to generate a lot of data, and then reads the data, and then it sends another M to stop the automatic flow of data, and then it closes the port. So this will be a very simple example, and let's see whether it works or not. So I will just run it step by step. So first we declare the object S, which will be the serial object, and then we open the communication in the next step and wait for a second, and then we send the IDN command and get the data in, and then we just translate it's called translation, right? The data, because it ends up enters in a 1 times x array, and we want it in a x times 1 array instead. And then we just change the mode on the board by sending an M over the serial port, and we just read a lot of data, and then we just print out another M, so it stops, and then it closes, and we just make it run to the end. So now you saw how I debug this program. I run it step by step. If I wanted to print the value of IDN, I just need to type IDN in here in the console, and there you have it, Arduino Uno revision 3. If I want to get the text that I got, I just type in here text, and here you go. That's the information that I got from the board. Okay, so now you've seen very quickly how I could interact with a program that just sends data through the serial port, and it's a couple of things you need to consider, but the interesting thing is that then you can parse this data, you can store it in CSV files, you can graph it easily, and so on and so forth. And for those of you that are using MATLAB, this can be a very, very handy tool. So let's take a look at the next example. And the next example has to do with the fact that inside MATLAB, you could configure different add-ons, and one of those add-ons are hardware add-ons. And here you have get hardware support packages. And there's hardware support packages for a whole bunch of different things inside MATLAB. And one of them is the Arduino Uno board, or an Arduino Uno Mega. It's a collection of Arduino boards. All the ones are cameras, because you could be reading cameras in order to do computer vision algorithms, and so on. So here you see that I already have installed the one for MATLAB support for Arduino and Simulink support for Arduino. And both of them are interested because they do a bit of a different thing. So the MATLAB support for Arduino hardware, it allows you to tether the board and read the data inside your programs, while the Simulink allows you to write code in the form of blocks and upload it to the boards. So I'm gonna first check out the one for MATLAB, and because we had a bit of an issue before when we saw a trick during the previous installment of this video, I'm going to directly go to the manager of my different hardware blocks and configure the board directly in the setup system here. This should be done by the software automatically, but we had some issues in the video before, and so I'm gonna just do everything from scratch. So in this case, what I'm doing right now is to reinstall the Windows drivers for the Arduino board. And this is not needed because my computer already has the Arduino drivers, but I'm just doing it for the sake of going through the whole step. Then I want to set up the Arduino board connection. This means that I want to manually inform where is my board connected, and you see it's on a USB port. It could be another board that runs over Bluetooth or Wi-Fi, and I will actively choose that this is an Uno board and that this is running on the COM13 port. And as you see, I could here configure different libraries that could be put by default on the board, because the way it works with the MATLAB support for Arduino boards is that it creates a big block of code, and then from MATLAB it calls different instances of libraries to do different operations on the pins. But that requires that all of those pins are pre-programmed and are loaded on the board. And I can say, okay, we need to have an I2C library, an SPA library, and a servo library, because I might be using them. I could also say I don't want to use them, I just want to read buttons, and I would turn all of these things off. So I click on program, and right now what we see here is that MATLAB is creating this big state machine, and it's gonna compile it, and it's gonna send it down to the board. And as you know, on Windows, typically the first time you compile something takes a little bit of time, and that's what we're seeing right now. And it's building the binary file out of the libraries, and then it will push them up to the board. It's gonna take a minute. And while it does that, I want to remind you that this is very similar to a technique that in Arduino we call the use of Firmatta. Firmatta is a software that runs on the board, so that you don't need to reprogram the board ever again, and you just request data from the board saying like, oh, what is on pin 1, what is on pin 7, what is on pin 5, or write to pin whatever, or write to the server that is on pin 9. And this particular case, this approach, requires that you're always connected to the computer, because the program does not exist in the computer. The board is just getting commands from the computer and responding to them, and that also will make that the board will be communicating all the time. So once this program is running on it, you will see how the TX RX lights are blinking all the time, because the computer will be sending requests to the board, that acts as a server, and so will be sending data back. So at every request there will be handshakes, and there will be data exchanges, and so on and so forth, and that will make the lights blink all the time. And nevertheless, it doesn't mean that the thing is not working. It's the opposite. It means that thing is working really well. So, and that approach is different from the one that we saw earlier when we were using the serial port, where we were just sending data on a program we have made specifically that was dedicated to that sole purpose of sending that data from the board up to the computer. Okay. In this case, the server configuration is bidirectional by design and allows you to do all sorts of operations. Sticking a little bit, as you see. So we're gonna give it a time up, and now it's done. So now it's being programmed. You don't see it, but the board is here, and you see the handshake, and it's done, and we got success. Okay, we click next. So now the board is ready to use, and I will click on text connection, and it's gonna make a test that the different libraries are working and handshakes, and it works fine. Perfect, we're done. And I could say here, show examples for the support package, and I will do so. And this opens the help for MATLAB, and I always like to say that MATLAB is one of the best self-documented softwares. It's so much help that sometimes there is even too much. So this is there's an example here that, if I'm not mistaken, I already have open on MATLAB, so I'm just gonna check so that I don't need to open it once more. Yeah, here it is. So this is the example for MATLAB that will run the Arduino code. And right now we're having, because I didn't bring anything with me, I'm gonna make the board work on pin 13. The example itself was working on pin 11. And the only thing you need to do is to configure that you want the board to be connected to a certain port. In my case, it's COM 13, and then which is the pins that you're writing, which are these ones. So I'm gonna take the board up in my hand and put it close to the camera, and I'm gonna run this program up to this digital pin 13.1 that should leave the light lit. Okay, so this will configure the object, and you see runs as you see on the screen, and sorry. So it's configuring the serial port, and we go to the next step, and now the light is gonna go off, and there you have it. The light is off, and we wait for 2 seconds, and when I hit on this again the next time, the light will go on. There you have it, and I will just click it till it runs this for loop to the end, and what this will do is to make the light blink 10 times and then end the program. And there you go. You see, the light that matters is the one with the L. The other two are just indicating that there is communication. But as you see, it works as expected, and now it's done. And it ends, because the program says so, with the light on. So this is the second method that we've seen before, and now we saw again on how to make the thing work. And now we're gonna see a last method, which is to use Simulink. And with Simulink, what happens is that you write the code in blocks. So I'm gonna go to the add-on explorer, sorry, no, the add-on manager, which is the other window. Here we have it, and I will do the setup for the board in here. Again, in theory, you don't need to do it this way, but I'm doing it here because I want to be safe, because it looks like this computer I'm having today is not responding really well, and I want to save some time because we did waste some time earlier with this. And looks like I didn't click properly on setup. Okay. So this will open up another configuration window that will allow me to change again the software on the board and make sure that the system is configured properly, and then we'll come to the examples and see a basic example of how to use this board with Simulink. Let me see, did I? No, probably I didn't click properly on the setup. Okay, now, so again, this is step-by-step setup of the board for Simulink, and here we go. It's gonna do the board detection. If it works fine, it will find it. If not, I will force it manually. It found it. You see COM13, say OK. Next. Do you want to verify the setup? Yes, please verify the setup. And test connection, and it's gonna compile a program and upload a program to test that it works, and it's gonna take a little bit because again, needs to compile from scratch, and so on and so forth. And here again, this is not a blank program. This is a program that is answering to the philosophy of MATLAB. So it creates a time base with keyframes, which has they have a certain frequency of sampling, and so it's running inside the board at a certain amount of ticks per second, and it analyzes the state machine every certain amount of ticks per second, and then we add our own state machine on top of the default time-based system, and it runs on top of that. So we will add a couple of blocks and see how it works. And the compilation always takes time, and that's something we have to live with, because especially on Windows, there's this thing about the OneDrive that every time you changing, or not OneDrive, but the journaling system, every time you're changing files, it's making backups and so on. So unless you have a very tuned computer where you specify that certain folders you don't want to be backed up, it always takes time to compile and upload. It's a Windows thing. The exact same computer running another operating system wouldn't happen. But anyway, the connection worked fine, so we are sure now that we can upload and work properly. And we're going to just take a look at the examples for this particular support package, which is Simulink. And here opens again. I'm going to open the default example that we saw earlier. That is a nice one and works for all of them. And this default example has a box that has a signal that goes on and off. And I wonder if I could actually zoom this a little bit. Maybe I could zoom in. Oh yeah, we can zoom a little bit. I will try to do some more zooming. Control plus. Great. And so this represents the Arduino board, and this represents the the signal. And if we do something here, this will be compiling to code that will address this one pin of the board. This is right now it's pin number 9. I'm going to make it pin 13, which is the pin where I have the LED right now. Also, I'm going to make sure that there is the right board connected in here, because that was an issue that I had earlier when I made the other test. That by default, this example had the Arduino Mega configured instead of the Arduino Uno. And again, you see, it has the Arduino Mega. It's because this example is compiled like that, but it allows you to configure to use other boards. So now we say we want to use Arduino Uno, and all of the other settings are fine. And then here we can change the frequency pulse generator. Right now the light is blinking at the speed you see here. if I change this, I will be able to change the speed. I'm going to make it a lot smaller. Apply. Okay. And now we'll deploy this thing to hardware. Here you go. And you're going to see the bar in the bottom here, which says that it's compiling, and then it will be uploading the software app. And again, the first time it compiles, it's going to take a little bit longer, but then it will just work fine. And when it's done, the light should blink even faster. And the upload is going to happen very soon because I already finished compiling. As you see, it's still working. It takes a bit of time, but as I said, it's mostly because of this particular computer. If there was an error, we will get a pop-up that will tell us about the error that happened, and we will be able to see what mistake we made, if any. Okay, wait a little bit. Okay. And that was programmed, and now you saw the handshake because the program was sent, and now we see how the light is blinking a lot faster. Okay, so now we saw the third method, how to communicate with MATLAB. We've seen three methods: like plain serial communication, then we used Simulink, where we upload the code and it stays there, and the last one, which we saw at the second position anyway, is MATLAB-based tether, where there is a server running on the board that responds to commands. Because as I said earlier, this program is now running on this board. If I unplug the board from here and I plug it into a different computer so it gets power from somewhere else, you will see how the program is working the same as before. So with Simulink, we do actually upload the program on the board and it stays there. And that's really, really powerful.
Okay, friends, thank you. This was it. I hope you liked it. And remember to subscribe to our channel. Remember to give us likes on the video and send any comments if you're interested in getting to know more. And stay tuned because the Arduino LiveCast is going to happen every Tuesday at 7 p.m. CET, and maybe also other days during the week whenever I have interesting content to show, like this particular video today. So see you soon on the internet. Goodbye.